All right, 1.4, absolute value expressions and equations. So first off, the definition. Absolute value of a number is written with these bars. And it's the distance is a number is from 0. Okay? The absolute value is always positive because distance is always positive. So if you think about your height, let's say you're 5'3". You're 5'3" whether you're standing up, laying down, or standing on your head. The distance is still the same. Okay, be very careful. When evaluating absolute value bars act as a grouping symbol. They are not the same as parentheses. Perform any operations inside the absolute value first. So we cannot distribute, all right? So like this, we can distribute. Very common mistake is people try to distribute here, and you cannot do that. That's a no-no. We always want the absolute value alone. All right, so evaluate. Evaluate means plug these numbers in for their respective letters. Okay, so I'm just going to rewrite it for absolute value bar. The x becomes -2 minus 2 parentheses 3 absolute value bar. Now I'm going to do everything inside the bars first. So for absolute value bars, -2 minus 2 times 3 is 6. So for absolute value bars, -2 minus 6 is -8. And now we don't distribute and get -32. We evaluate this. The absolute value of -8, how far away from 0 is -8? It's 8 spaces. So now that's 32. Very common error is -32. Now when solving equations, we want to know all the possible solutions. So what could be in here for this to be true? Well, think about what numbers are 5 away from 0? Well, it could be -5 or +5. Both of those are possibilities. So, in this case, possible solutions for this are -3 and +3. So, therefore, we could have 2 problems to solve. So what we do in this case is we are going to branch off into 2 different problems. We're going to write 6x minus 3 equals 15, but we're also going to say 6x minus 3 equals -15. There's 2 separate problems. Because if you think about it, we just said this could be -3 or 3. So we're going to say, like in this case, x equals 3, like we see it, and x equals -3. That's why we set it up this way. Now we're just going to solve just like we did in previous lessons. We're going to add 3 to both sides. That's going to give me 6x equals 18. And I'm going to divide, I'm not going to show it here, 3. Okay? But now when I add 3 here, notice I get 6x equal to -12. Therefore, when I divide, I get -2. Those are my 2 possible answers. And I can check that real quickly in my head. 6 times 3 is 18, minus 3 is 15. The absolute value is 15. 6 times -2 is -12, minus 3 is -15, and the absolute value of that number is +15. It works out. So the absolute value is always going to be either positive or it could just be 0. So when we have something like this where it ends up being equal, an absolute value is equal to a negative number, that's never true. That is called an empty set, and you can use either one of these for that. But be warned, you could work the problem out and get a beautiful answer, like you get a number, but if you go back and check it like I did on the previous problem, it doesn't work out. And that's called an extraneous solution. EXTRANEOUS, extraneous solution. So it's an answer, but it's a lie. All right, so steps. Get the absolute value by itself. So remember, we do not distribute. So if there's something outside, I can spell, if there's something outside the absolute value bars, we do not distribute it. We have to divide to get rid of it. Write two problems, like we've already done, solve and check. This is the most important thing. You have to check your answer. All right, so here's my absolute value. Okay, it's right now being divided by 2, which means I need to multiply by 2. Okay, when I do that, I get the absolute value of 2x plus 3 equals negative 20. All right, so in this case, I'm ready to break it up. But I notice that this is a negative number. It can't be set equal to a negative number. Therefore, we're already done. It's no solution. The most common mistake here is that people go ahead and do this. And I'll show you. You don't have to write this down, but just watch. You can do 2x plus 3 equals negative 20. And you subtract 3 and you get 2x equals negative 20 over 3. Sorry, negative 23 I meant, right? I got ahead of myself because we're going to be dividing by 2 next. And x equals negative 23 halves, okay? Or negative 11 and a half, all right? But if you check the answer, you may not come up with a true statement, okay? Because if you think about it, plug this in, no matter what you plug in, it's going to be in positive, and a positive number divided by 2 is not going to give you negative 10. So this ends up being not true, which is why you have to check your answer. All right, same thing here, except this time when I divide by 5, to get rid of this 5, okay, I'm dividing instead of multiplying, but same concept, I'm trying to get rid of that. When I'm done on this side, I do have an absolute value equal to a positive number. So in this case, I am going to set up my two equations. 2x minus 1 equals 5, and 2x minus 1 equals negative 5. Now I do all the steps I've been doing. I'm going to add 1 to both sides and get 6. When I divide, I get 3. I'm going to add 1 to both sides. I'll show the work here because we have a negative and a positive. That's going to give me 2x equals negative 4. Then when I divide, I get x equals negative 2. Now, those are my two answers I've got, but I need to plug them in and check them. So when I plug this in here, 2 times 3 is 6, minus 1 is 5. Absolute value of 5 is 5 times 5 is 25. That checks. Negative 2. Negative 2 times 2 is negative 4. Negative 4 minus 1 is negative 5, but the absolute value of that is positive 5. And we multiply by 5 and get 25. So even if this is a positive number, there's a chance you could end up with an extraneous solution, so you always have to check. Now here, notice, here's my absolute value bars. It's being multiplied by 3 and subtracted by 2. This is kind of like if I had something like this, 3x minus 2 equals 10. My absolute value bars is my x that I'm trying to solve for ultimately. So I need to get rid of the 2, then the 3. So I'm going to add 2 to both sides. And that's going to give me 12. Okay, add 2 will cancel. 10 plus 2 is 12. Now I'm going to divide by 3. So absolute value, x minus 4 equals 4. Now at this point, I'm ready to set it equal to two different equations. X minus 4 equals 4. And x minus 4 equals negative 4. So when I add 4 to both sides, I get x equals 8 here, and x equals 0. I'm going to check them real quick, plugging in here. So 8 minus 4 is 4. Absolute value is 4 times 3 is 12, minus 2 is 10. Check. 0 minus 4 is negative 4. But the absolute value of that number is positive 4. 4 times 3 again is 12, minus 2 is 10. Check. Those are my two answers. And they both work. And that's it.